Hey everyone, I'm Logan from 6277B One Pancake, and I'm really proud of the robot that we built this year, so I wanted to make an explanation video and talk about the robot a lot. And since me and my teammate, or sister team from 6277F, both got the Build Award at Worlds, we wanted to make a duo explanation video.
Yep.
Hi guys, I'm Henry He from 677F, but on pushback year, I'll be on 677B team as a builder.
Cool.
Yeah?
Alright.
Let's get into it.
Alright, so I want to start with our chassis. It's a pretty typical chassis. It has 4 wheels that are all omnis, so we can slide a lot easier and be more nimble. Another thing with these wheels is that we have the wheels on the inside and the gears on the outside for 2 reasons. The first is so that when people are playing defense on us and they try and hit us, the gears get chewed up instead of the omnis, and you can see like all of our rollers are still in place. And then also we have the wheels on the inside for a smaller turn radius, because, here, you can pan towards me, Jack. If the wheels are really far out, then you have to turn all this distance. But if the wheels are really close together, then you only have to turn a small distance to turn that same amount. Another thing also is we have a lot of support on the robot because we had this bot for 3 months from launch until Worlds. And as you can see, we have 3 full-length supports with standoffs in between all of them. And then we have 3 mid-length supports as well. And the robot, as a frame, it never really bent, and I'm really happy with that. Oh yeah, and then also the robot's 450 RPM with screw joints, zip tie bearing flats, and a lot of the stuff you see on most robots nowadays. And am I forgetting anything, Jack?
I also feel with the gears on the outside, there's less risk of us crossing the auto line.
Oh
we
yeah,
went parallel
the wheels
to it.
are, yeah.
Yeah.
And then just a bunch of standoff support everywhere, like here, just to keep everything perpendicular. Oh, actually, another thing I want to say is, like, when building your frame, I'll flip it over for this, is you should really start, at least in my experience, with these 2 pieces of metal and then put standoffs in between them, because then you know that these 2 pieces are perfectly parallel. And then mirror it on this side and then build all of your cross support. I know people are mostly going for lighter robots now, but then you put all those together and then you know that all these pieces and these pieces are all perfectly parallel when you put them together, so it doesn't really risk anything bending or being at an angle.
Okay, so this chassis is, have some similar points with Logan's, but I have my own thoughts in it. So very typical 3 cross supports, and all omni wheels here. But what's different is I have 600 RPM direct drive to our wheels for our chassis, which have 2 benefits. One is I can run screw joints with spacers in between, so that it makes sure that both C channels is never gonna bend into each other. And another good thing is the wheels, they have better free spinning without the gears. More things to mention is the anti-tip wheel, is because for this year we need our mogul to go into here, which limited our motor placement, so that our motor can only place a little bit front. That leads to a space blank out at the back, so that I have to add a anti-tip wheel. And it works perfectly when it's accelerating. It will, when we accelerate, the robot will pop up, and then the anti-tip wheel will get it back to the ground. More things to mention is our air tank placement. Our air tank placement is right here, so that it provides a very low CG compared to other chassis. And that will lead us to one more benefit, is we can run all our T's and ear tubes at the bottom of the C channels, where it's very safe, so that it's impossible that anyone could touch them. Yeah, and that's pretty much it.
Alright, next subsystem I want to talk about is the intake. I really liked it because it was simple. It has really good pickup ability. It was just really smooth and easy. Like, it would just pick up rings with barely any force. So I really liked that. And something that really contributed to that, or actually the 2 things, were, 1, using smaller flex wheels. And it's because we use, or the smallest size, they have more torque. because the radius of, like, it's hard to point out because they're tucked in, but the radius of the wheel is smaller, so it has more torque on the rings. And then the other thing was this piece of plexi down here, which I really liked. My driver and I, Dan, spent a lot of time like coming up with something and figuring out what we should get, because a lot of teams either had something that like dug into the mat so they couldn't drive forward, or that was too high up, so they struggled with like actually picking up the ring. But this is great because we could tilt forward or tilt back, and unless we're tilted back like that much, it was always perfectly flush with the ground because it just has its own weight. But then when we're driving forwards, it's not digging into the ground, so I really like that. And then also we used these pneumatic tubings as well, which was a cool little bit of tech we found, and we just pinned them down with these screws, and it allows it to be like really adaptable to whatever ring's coming in without having to be like a whole giant piece of plexi or anything. And just put a loop of pneumatic tubing on. Oh yeah, and then also we just have all the other stuff like tucked in here, like our chain is tucked into the side just so no one could snap it. And we have, once again, just like everyone else, a bunch of half cut 24 tooths just to switch it so that the chain and first stage are going the opposite direction. And yeah. Oh, actually, last thing I do want to mention is the fact that the whole front of the intake does wiggle, and this is on purpose because it's kind of a weird way we put the motor on. As you can see, it's tucked in down here for a better CG and a good gear ratio of 480 instead of 600, because it lasted for a lot of practice sessions that were over an hour long. And because this is such a weird way to mesh the gears, by using shoulder bearings and having this whole part wiggle, it let the whole intake be really low friction. As you can see, like when I move it, it's really easy to move. And other just typical stuff as well that I want to add on is like we have an intake lifter and a front shield as well to pick up the rings, but everyone has those. Those aren't really that interesting. And yeah, surgical tubing as well, just to stop rings from flying out, but that's not that interesting. Yeah.
So now it's my intake. One thing that's both Logan and we all have is this cross support right here that's a 45 degrees with the steel rail underneath the Lexian, so that when we get hit on the front of our intake, this standoff will absorb the force that way and then that way. Okay. And yeah, our chain is stuck in the C channels, and because our intake is lifting up and down, I have to make this chain a little bit loose just for it to not snap around.
Surgical tubing as well.
Yeah, surgical tubing, as Logan said, to prevent the rings to fly out, and also it can pull the whole intake system up so that we're not pushing onto the ring, that we're more grabbing the ring inside to our intake second stage. One more thing to talk about is our flats here. So the purpose of this is to make sure that the rings doesn't fly out when it's intaking. How it works is, due to the fact that the rings have weights, that whenever there's only hooks, I've tested it, it will go up like that, and then whenever it got stuck, it either snaps or it just tosses the ring out. So this flaps right here really help us to just make sure, yeah, the rings dunk on the Mobile Go.
And disperse the weight as well.
Yeah, disperse the weight. Cool. Something I forgot to mention, which I want to add, is our intake part. So you can see our motor is here because I want the center of gravity to be as low as possible. And then it runs a light shaft here to a little sprocket, and then to a sprocket here, transfer the power to the tower intake. And then this whole shaft come to here, small gear to a big gear, down to the front intake part, which reverse the rotational direction for two intakes, and that'll make our intake works. I'm gonna talk about the doinkers right now. or the yoinkers, or whatever, you know. We have 2 of them on both sides. What?
Nah, keep going.
Okay. We have those shoulder bearings for the heavy shaft, but instead we run a standoff in between because they're low friction when they're, you know, rotating. Plus, they're much more stronger than just only a screw or a light shaft running, and it's lighter than a heavy shaft. So I chose this for the joint of the 2 doinkers jaws. But whatever, when it drops down, you know, it goes in, it clamps, it takes that away from you, and you're gonna say what? No. Yeah, that's what happens. But didn't happen a lot, but
Yes, you have the piston in there.
yeah, a little piston in there, and then this standoff have a little bit more range on here, so that when our opponent is, you know, clamping it on their robot, that this standoff is short enough that I can go in and then just grab it from him away to pull him back from defending the wall stake and stuff. You guys know, you guys seen a lot of videos.
Yeah, on both sides.
Yeah, on both sides, it's legit the same design. But one fun thing that to say about is those cutoff that I designed it for the pneumatics here. So the pistons here, it's always a pain to run the tubes out from the pneumatics piston. So when I designed it, I just cut off a thing, you know, for the L pneumatic thing to run off the tube, and then it could go back to our bottom, these, you know, gathering family, the T's. All right,
And
yeah, that's
Alright, my doinker compared to Henry is kind of trash, not gonna lie. Pretty simple. I took the band off just so you guys can see it down. 75mm piston. What else is special about it? Oh yeah, and then it's also the same as Henry's. It has a piece of C-channel with a coupler inside of it, and then 2 heavy shaft bearing flats, just so that's really strong, and like if we're slamming into the wall, it's not gonna break. And it's also just on a heavy shaft that's just pinned down with 2 screws to the chassis, so it's pretty strong and well connected to the robot. Oh yeah, and then we also have this piece of Lexan. It got the job done for clearing the corners, and we also added this little hook at the top just so that a ring, couldn't like get stuck. Well, I guess it can if you like throw it on, but if it comes at the piece of plexi, it used to be able to like just fit right on, so we had to add this, and we never had any troubles with it getting like stuck, especially because it was band powered as well. If a ring came on it, it wouldn't be able to come back up. And then also, I guess while I'm right here, we have a bunch of good geometry in here with an equilateral triangle, which is really strong, and just kept our tower up as well, because this put a lot of force on it as the piston just kind of slammed into the ground. So we have this heavy shaft right here just to make a nice triangle and brace the tower.
well, wait, one more thing is whenever you want to do this kind of joints, make sure when you screw a screw underneath to the C-channel, you make sure this thing is boxed with a standoff or whatever, so that you don't bend the C-channel.
Yeah, good point. Always box
Yes.
your bots. Alright, next thing is the clamp. I really like this clamp. We had a goal stolen from us, and my driver had a little crash out, and we were like, we needed a locking clamp. Don't mind the wraps falling off. They were good for worlds, and that's all that matters. Oh yeah, and also same thing that Henry had as well. We have a little standoff tucked in here, just so that these 2 pistons, we didn't have to do anything like wonky with screw joints, and they're just well connected together with the standoff going all the way through. And Heike, the best way to explain how this locking clamp works is with your arm. You can pan over to me, Jack. Is like your arm is completely normal until your elbow goes past a line in between your shoulder and wrist. So you can push back on your arm. I said the thing. Until your elbow though, you can keep filming. Yeah. Until your elbow goes past the line in between the 2, and then your arm can't get pushed back anymore. And so, but once it's popped back, your arm's back to normal. So it works the same way with this. Once actually I should explain, the shoulder would be here, the elbow's here, and the wrist is here. And once this snaps into place, the elbow is tucked behind the shoulder and wrist. And now when someone tries to pull up, and there's even a tiny bit of force here, it doesn't matter unless you're like ripping through the metal. It won't come out. But then when with the well-placed surgical tubing, it just pops it right back to place. And you can see, I'll just push this in, make sure it's actually in. As you can see, like, I mean, I don't need the bottom anymore, but like,
Oh,
yeah.
yo. Okay, so Logan's clamp is pretty good, but mine is I want to use that for a example for the what you want to avoid when you want to build something like this. So we both have a locking clamp, but mine, you can see when I goes down, I need a little bit piston power from here to really push the whole thing down, which it's not really good. And why that happened is because we run the long screws to the 3Y, cut it to 1x1 piece of the metal that's kind of wiggly jiggle, and that's kind of a little play on our clamp. But with this intake, it works well. It dunks on the mogos, but myself, I'm just not very satisfied with it, but it does the job. And whenever you want to put a screw in here to connect into the standoff, you always want to put a Loctite on it. This time I was too rushing. I didn't put Loctite, so the screw fell out. You guys don't want to do that. Other than that, the locking clamp is a really good thing to pick up. You can learn it from everywhere. You can see it from anywhere. And yeah, that's our clamps.
All right, onto our ladybrown now. As you see, it's kind of funny. We don't have any cross support in between. It's because we don't want the cross support to like clinch these two in. And if they like pulled in too much, then it's much harder to prime it. Hold up. As you can see, it has a really nice and simple prime and just comes up, and it's really easy to dunk onto the wall stakes. And that's all because we don't have any support in between. And also, actually, I'm going to bring it down. If a ring comes in kind of at a weird angle, then because these two are independent of each other, then the ring can be tucked in kind of like that. And jack back up, I don't want to hit you. And it'll still score even if the ring's at a weird angle. And then the other thing also on our ladybrown is our hang. And it's kind of a really janky hang. We brought a lot of backups because it's really small and really breakable. But the one thing I really do like about it, besides for the fact that it works really well, is that if the bars is like right where my forearm is, we can just drive straight at it, and then we'll just ride right over, and then we can drive backwards. So it was really easy to just drive like that and come back over.
All right, now let's hop into the ladybrown and a little bit of the hanging action. First thing I want to point out is I love those custom Lexan bearing flats that they works as a thing just to squeeze them together, but also as a bearing flat. It makes the whole structure thin and looks nice, plus it's weight savings compared to using a flat piece right there. What else? Oh, the rotational sensor. I love the rotational sensor a lot, just because I have both Lexan on two sides, because we're using 2 half watts for the ladybrown, and the rotational sensor being at the middle will make the whole structure looks symmetrical on both outsides. And the fact that there's 2 pieces up down holding them makes the rotational sensor not going to anywhere, that it fits right in the middle, and it's always accurate to the prime angle. Yeah, and ladybrown, we're using typical cut-it 3-wide piece right here. They're stronger than a 1x1 piece that's from the Vex factor. Yeah. And now let's get into the hang. The hang is also cut it 3-wide into the angle piece, where I box all of them inside. And we have a golden insert that free spinning, so that, you know, less friction when we goes up to the hanging action. And then running with this heavy shaft shoulder bearing, with the angle piece right here. In between those, I have a custom cut polycarbonate just to fit as a really small tiny bearing fat as this one, and also as this one. They work very well, nothing goes offset. And then because of this whole thing is boxed, and I have this structure here that I'm super confident that I didn't even bring backups for my hang. And that's my hang and ladybrown.
Alright, so the last couple of things I want to talk about for this robot. The first are the mag plates. Rest in peace. Really tragic that you guys can't use them anymore, but they're really convenient, really nice. Kind of a pain to like glue them all together, but I really liked using them. They were definitely not weight savings, but I like them a lot. The next thing is some tech from the old 6277B builder. If anyone remembers him, his name was Blake. But it was about color coordinating your wires. So if I wanted to test, for example, the intake motor, instead of having to like try every single one, I just look, see that there's gray tape on it, see that there's gray tape on this wire, and I know that port 20 is the slot that has the intake motor on it, which I felt is really helpful and really good for the build interview. And something else for that as well is just having really neat wiring. Definitely not going to actually help your robot's performance, but once again, really good for the interview for a build. And actually, just while I'm on that note again, is this right here is just some remote air filling. It's part of like one of the new air tanks. That's this golden yellow part, and then this part is taken off of a pressure valve, and you screw them together. And I put this little, I don't even know where I got this from, but I think it's on the pressure valve or the limiter, and you just put this little nut on the end, and it just lets you fill up your air wherever you want. And I found that to be really helpful. And then the last thing I wanted to mention is the center of gravity. So everyone knows you should have your center of gravity as low to the ground as possible to just stop the robot from tipping up and down, or rocking back and forth, I should say. But the other thing is having your robot center of gravity like tucked in more. So just like a ballerina, I'll stand up for this, is if your center of gravity is really far out, you're gonna turn really slowly. But if your center of gravity is really tucked in, you're gonna turn much faster. And so that same concept applies to the robot, where if the center of gravity is really tucked in towards the center, you'll have snappier and better turns. And that's just about it. Good luck and pushback. Woo!
All right. And now I want to show some things that I like that are little structures on my robot. So one of those, we start from this. It's to hold this one piece of flat right here, because whenever the intake starts spinning, the flat will want to go back and forth, like forward and backward. But with this piece on, it really holds the whole flat piece right here, which is not gonna bend the standoff here and keep the good small friction in between the gears. And going back to here, that I really love this structure just because it's very light and very low profile. It's also very steady, that it holds our whole tower, no wiggle jiggle, at least for the tournament, or at least for the tournaments we went to. How this structured is a long screw to here, and then with spacers in between and gussets for pneumatics. That when I put a lock nut inside, that just squeeze this metal in between the gussets and the lock nut. Also provides a cross support in between those two C channels. So I love this a lot. Yeah, more things to talk about is the brain placement on my robot. It's actually a quick change brain that I can just pop it off. What else? Also the battery placement is right here. I don't have a clip. My battery is like mashed inside with this protecting it. This used to have a screw going in, but I took it out. this goes inside, and then rubber bands to hold it in, that it's not gonna come out during a match. And what's even better of those two placement is with the batteries here, or with the battery here and the brain here, as Logan said, the ballerina example, that both of those center of mass is very towards in the center, that when we're turning, we're super fast. We're just super fast. Yep. Oh, and more things to talk about. One last thing is our how close our solenoids with the pneumatic piston. You want that because it will save air whenever you activate and deactivate, because whenever you activate, it pops the air into this distance between your solenoid and your pneumatic piston. So the shorter in between your solenoid and piston, the more air you save in your whole air tank. And I do this trick on all of my robot, which ended up save more air for my doinkers that use a lot of air because it's 75 millimeter, that I get to use them several times during a match. So it can also work as a what's the word? Structure. Now the bearing flats.
Oh yeah.
Yeah, I'm Chinese. So, and then so back to those ladybrown.